Google has just released Gemini, and from all the measures, it seems to beat GPT-4, and it includes a lot of crazy innovations, which are just so interesting. So we're gonna go over all of it today. I read the research paper in full and highlighted the most important bits. We're gonna look at some of the promotional videos showing off what it's capable of, and we're gonna see, is it gonna be better than GPT-4? Let's go. So the first thing I want to show off is this promotional video, which absolutely blew my mind. And it shows off some of the multimodal capabilities of Gemini. And Gemini is multimodal natively. It doesn't have different models that are rolling up into a single model to support multimodality. It is multimodal. So let's take a look. So the first thing we're going to be looking at is this video, which shows an interactive example using Gemini. And the human user, which is shown in this left video box right here, is going to be chatting with Gemini in real time. It's pretty crazy.
I see a squiggly line.
What about now?
The contour lines are smooth and flowing, with no sharp angles or jagged edges.
So he continues to add to this little drawing of his, and Gemini continues to update what it thinks it is. And this is a great example of image recognition, video recognition. It's pretty impressive.
Looks like a bird to me.
What if I add this?
The bird is swimming in the water. It has a long neck and beak. It is a duck.
Yes.
A duck is a type of waterfowl in the family Anatidae. Ducks are closely related to geese and swans. The duck appears to be blue.
Okay, so as it's analyzing the image, the person is updating the image. Now he's coloring it in blue, and now Gemini says the duck appears to be blue. So as the video is going on, Gemini continues to read from it and update its understanding of what's going on in the video.
This is not a common color for ducks. However, there are some breeds of blue ducks. These are typically not as common as other duck breeds. It is more common for ducks to be brown, black, or white.
Are you sure?
What the quack?
Okay, now the person brings in a rubber ducky, and Gemini has a personality. What the quack? This seems like what Grok is meant to do as well, which is X.AI's AI. It's supposed to have a little bit of personality, and this is something that ChatGPT does not have at all. So this is pretty funny. What the quack? I mean, it's corny, but it's funny.
I was just talking about a blue duck, and now you're holding one. It looks like blue ducks are more common than I thought.
Would this float?
I'm not sure what material it's made of, but it looks like it might be rubber or plastic.
What if I tell you it's making a squeaking sound?
Oh, if it's squeaking, it's definitely going to float.
Okay, so the person asks, is this going to float? And Gemini says, I don't know what it's made of, so I'm not sure. And then he says, oh, but it squeaks, squeezing it and squeaking it, showing that there's air inside. And yeah, it's going to float if there's air inside. And let's see what Gemini says.
Nice.
It is a rubber duck. It is made of a material that is less dense than water.
Can you teach me how to say this in a different language? And give me a few options.
Okay, now he's asking about different languages. I mean, it's super, super impressive. And it's also natively multilingual. All right, here's a cool one. In real time, he's going to create a game where Gemini needs to come up with a description of a country or location and use emojis. And then the user is going to point to it on the map, and Gemini is going to say if it's right or wrong. Let's take a look.
Okay, based on what you see, come up with a game idea. Oh, and use emojis, please.
How about this? We can play a game called Guess the Country.
Sure, let's do it.
Clue 1. This country is the home of the kangaroo, the koala, and the Great Barrier Reef.
Oh, that's easy.
Clue.
So cool. So Gemini came up with the game, came up with the rules of the game, gave a hint as to what country it's talking about. The user points to it, and Gemini knows it's right.
Clue 2. This country loves football and has won the most men's World Cups in football history.
All right, now they seamlessly switch to something completely different. The person crumpled up the piece of paper that had the map on it, has 3 cups now, and threw the crumpled up paper under one of the cups. Now, as a human, I know where he's going with this. He's gonna start shuffling the cups, and the game is to track which cup the ball is under. Let's see if Gemini understands it.
You are trying to get me to find the paper ball under the cup. I accept the challenge. The cup to the left.
How incredible is that? Without giving it any instruction at all, just the video, no instruction as to what the game is, Gemini understood what it was supposed to do and did it successfully. Tracked the cup after its movement to the right position. Okay, I'll show a few more of these later, but for now, I want to go over the research paper, and we're going to discuss a bunch of data about Gemini, how it performs against GPT-4 most impressively. All right, here we go. Gemini, a family of highly capable multimodal models. So this report introduces a new family of multimodal models, Gemini, that exhibit remarkable capabilities across image, audio, video, and text understanding. So it is multimodal natively. So this is very different from other models that we've seen so far. And the models consist of Ultra, Pro, and Nano sizes, suitable for applications ranging from complex reasoning tasks to on-device memory-constrained use cases. So that is why they have multiple models. And we'll talk more about that in a minute. Our most capable Gemini Ultra, which is also the largest model, advances the state-of-the-art in 30 of 32 of these benchmarks. So basically, it is beating every other model in the majority of benchmarks. And it is the first model to achieve human expert performance at the well-studied exam benchmark MMLU. Okay, so let's dive into the details. We trained Gemini jointly across image, audio, video, and text data for the purpose of building a model with both strong generalist capabilities across modalities alongside cutting-edge understanding and reasoning performance in each respective domain. Ultra, the Ultra version of the model, is used for highly complex tasks. Pro for enhanced performance and deployability at scale. So most likely the Ultra is going to need a crazy system to power it. But the Pro is kind of right in the middle, where everyday users like you and me can probably spin up a GPU either in the cloud or maybe even locally to get it running and working well. And then Nano is for on-device applications. This is their direct shot at Siri. This is going to be Google AI on your Pixel phone or wherever else you want it to be. Each size is specifically tailored to address different computational limitations and application requirements. All right, so first let's talk about Gemini Ultra, their biggest model. It achieves new state-of-the-art results in 30 of 32 benchmarks we report on, including 10 of 12 popular text and reasoning benchmarks, 9 of 9 image understanding benchmarks, 6 of 6 video understanding benchmarks, and 5 of 5 speech recognition and speech translation benchmarks. It is also the first model to achieve human expert performance on MMLU, a prominent benchmark testing knowledge and reasoning via a suite of exams. Okay, now let's look at this example. In this prompt, the user says, here's a solution to a physics problem by a student. So a skier slides down the frictionless slope as shown. What's the skier's speed at the bottom? This is all hand drawn, very messy. And then it says, try to reason about the question step by step. Did the student get the correct answer? If it's wrong, please explain. Make sure to use LaTeX for math and round off the final answer to 2 decimal points. So this is really integrating a bunch of different modalities. It's reading the image, it's using math, it's using reasoning and logic. It's just super impressive. So the student did not get the correct answer. The student made a mistake in the calculation of potential energy at the start of the slope. So it goes through all of the math here, figures it out, and gives the correct answer. Okay, and then here at the bottom, verifying a student's solution to a physics problem, the model is able to correctly recognize all of the handwritten content and verify the reasoning. On top of understanding the text in the image, it needs to understand the problem setup and correctly follow instructions to generate LaTeX, which I believe is the notation for this math right here. And the reasoning capabilities of large language models show promise toward building generalist agents that can tackle more complex multi-step problems. The AlphaCode team built AlphaCode 2, a new Gemini-powered agent that combines Gemini's reasoning capabilities with search and tool use to excel at solving competitive programming problems. So basically, this is their version of agents. It has all of the capabilities of Gemini, the multimodal capabilities, and then you can give it tools, web scraping, an environment where it can actually execute code. And AlphaCode 2 ranks within the top 15% of entrants on the Codeforce's competitive programming platform, a large improvement over its state-of-the-art predecessor in the top 50%. And then we advance the frontier of efficiency with Gemini Nano. So let's talk about Nano for a minute. A series of small models targeting on-device deployment, so your phone, and really no internet. That's the key here. So for the Nano devices, no internet is required. These models excel in on-device tasks such as summarization, reading comprehension, text completion tasks, and exhibit impressive capabilities at reasoning, STEM, coding, multimodal, and multilingual tasks relative to their size. Really cool that they're coming out with multiple different models here. And they're using transformers. So this is really important. Google's team was the first to publish the transformers paper, which really transformed the world and allowed OpenAI to use that research to build GPT-3, 3.5, and 4. And it's doing the inference on TPUs, which is Google's own chips, and it has a 32,000 context length. So let's summarize the three different models now. We have the Ultra, our most capable model, state-of-the-art performance across a wide range of highly complex tasks, and it is efficiently serviceable at a scale on TPU accelerators. Then we have the Pro model, which is a performance-optimized model in terms of cost as well as latency, and delivers significant performance across a wide range of tasks. So if you don't want to get a huge TPU box going, this is what you would use. And then Nano, which comes in 1.8 billion and 3.25 billion parameter models, and you get to run these on more memory restricted devices. So 4-bit quantized for deployment and provides best-in-class performance. So your mid-low-end computers plus cell phones. And Gemini models are trained to accommodate textual input interleaved with a wide variety of audio and visual inputs, natural images, charts, screenshots, PDFs, videos, and they can produce text and image outputs. So they can't quite produce video output yet, but I bet that's coming soon. And it does have video understanding. So it says here, video understanding is accomplished by encoding the video as a sequence of frames in the large context window. And here's a good diagram of how everything breaks down. So we have the input sequence, text, audio, images, video. It all gets translated to the transformer. Then we either decode to text or image. And so that is the workflow of Gemini. Now here's something really interesting. For the Pro model, the inherent scalability of our infrastructure and learning algorithms enable us to complete pre-training in a matter of weeks. So it did not take them long for that Pro model. And then the Nano series will power our next generation on-device experiences. So let's talk about the training dataset now. Gemini models are trained on a dataset that is both multimodal and multilingual. Our pre-training dataset uses data from web documents, books, and code, and includes image, audio, and video data. So as far as I can tell, although maybe I missed it, they don't actually go into the details of what datasets they're using. Now, Google being Google has probably the most incredible dataset of any of the companies, maybe besides Meta. They have Google Search, they have Gmail, they have YouTube, which is an incredibly rich data set. And down here it says we apply quality filters to all data sets using both heuristic rules and model-based classifiers. We also perform safety filtering to remove harmful content. So it is almost definitely going to be censored. We filter our evaluation sets from our training corpus, and that has to do with contamination. So they really wanted to make sure that their evaluation data is not contaminating their training sets. And of course, I have a video coming all about that topic. So let's talk about evaluation now. How does it perform? One open question is whether this joint training can result in a model which has strong capabilities in each domain, even when compared to models and approaches that are narrowly tailored to single domains. So basically what it's saying is if we try to do everything, text, video, audio, images, every single type of knowledge, every single field, every single industry, are we going to be as good or better than models that are trained specifically on images or specifically for a specific industry? So academic benchmarks, we find that the performance of the Gemini Pro, so that is their mid-tier model, outperforms inference optimized models such as GPT 3.5 and performs comparably with several of the most capable models available. And Gemini Ultra outperforms all current models. And that is really, really important to take a look at. So when Gemini Ultra is available and you have the choice between going to GPT-4 and Gemini Ultra is going to, in theory, have better results. So on MMLU, Gemini Ultra can outperform all existing models, achieving an accuracy of over 90%. And MMLU is a holistic exam benchmark which measures knowledge across a set of 57 subjects. Human expert performance is gauged at 89.8. So as a human, if you get a score of 89.8% on the MMLU test, then you are an expert in your field. And Gemini Ultra in all fields achieves 90%. So that is insane. Let's pause there for a second. That is absolutely insane. So in any domain, Gemini Ultra is going to perform better than the human experts at that domain. And the prior state-of-the-art result was 86%. So under the human expert level, but now Gemini Ultra is over it. And here's something really interesting. We find Gemini Ultra achieves highest accuracy when used in combination with a chain of thought prompting approach. So this chain of thought prompting approach really gives large language models a distinct advantage in quality and performance. Okay, so here it says for the GSM 8K, which is grade school math benchmark, we find Gemini Ultra reaches 94.4% accuracy with chain of thought prompting and self-consistency compared to the previous best, which was 92%. And for increased difficulty math problems drawn from middle and high school math competitions, the math benchmark, Gemini Ultra model outperforms all competitor models, reaching 53.2 using 4-shot prompting. And Gemini Ultra also excels at coding, a popular use case of current LLMs. All right, so let's take a look at this graph. This is super interesting. So over here we have Gemini Ultra, then we have Gemini Pro, but let's compare Gemini Ultra to GPT-4. So as you can see, for every single benchmark except HelloSwag, Gemini Ultra beat GPT-4. It didn't completely blow it out of the water, but it beat it consistently across the board. And HelloSwag is common sense multiple choice questions. And in fact, GPT-4 did quite a bit better than Gemini Ultra at this one test. Everything else, it seems Gemini Ultra is the winner. Now here they talk a little bit about contamination, which I'm super interested in, and as I said before, I'm creating a video all about it. Evaluation on these benchmarks is challenging and may be affected by data contamination. We performed an extensive leaked data analysis after training to ensure the results we report here are as scientifically sound as possible, but still found some minor issues and decided not to report results on, for example, lambda. So they didn't report results where they did find contamination. And again, reminder, contamination means that the benchmark data, what it's being tested against, is not found or is found, if it's contaminated, in the training set to train these models. Because if you have the benchmark data in the training set for the model, then obviously they're going to perform really well when asked that exact question. And I think I'm especially excited for Nano because that really promises to bring large language models and the nano large language model to any device offline, completely run by the silicon on the device, which is very exciting for me. Obviously, I wish all of this were open source and we can fine tune it as we like and actually see the data sets, but maybe that'll happen eventually. But it being Google and them really competing directly with OpenAI, I doubt that's going to happen. So Nano 1 and Nano 2 models engineered for on-device deployments. These models excel in summarization, reading comprehension with per task fine tuning, and despite their size, they show exceptionally strong performance on factuality, retrieval-related tasks, significant performance on reasoning, STEM, coding, multimodal, and multilingual tasks. And it is extremely good at translation. So here's Gemini Ultra, and here's GPT-4, and it beats GPT-4. It's basically about the same, but it beats it across the board except for into English. All right, now let's talk about long context. So context size matters. And not only does the context size matter, but the performance at each context size matters. So you can have a 200K context window, but unless the model can actually perform well with 200,000 tokens, it's pointless to have that big of a context window. Gemini models are trained with a sequence length of 32,000 tokens. We find that they make use of their context length effectively. We verify this by running a synthetic retrieval test. We place key value pairs at the beginning of the context, then add long filler text and ask for the value associated with a particular key. We find that the Ultra model retrieves the correct value with 98% accuracy. That is really, really good. Now for complex reasoning, which I've been talking a lot about lately, Gemini can also be combined with additional techniques such as search and tool use to create powerful reasoning systems that can tackle more complex multi-step problems. So we've been talking a lot about that lately. Logic, reasoning, Q-star, all of these things are related, and Gemini seems to perform logic and reasoning really well. AlphaCode 2, a new state-of-the-art agent that excels at solving competitive programming problems. It uses a specialized version of Gemini Pro tuned on competitive programming data similar to the data used in Lee et al. So I'm very, very excited to see a model that performs really well at coding because honestly, I can't code anymore without ChatGPT as a partner. So I'm excited to get another partner in the mix. And it also does exceedingly well at image understanding. So high-level object recognition using captioning or question answering tasks. And so let's take a look at this. This is is Gemini Ultra right here. Here's GPT-4V, and you can see it actually performs better across the board. Again, not blowing it out of the water completely, but still doing better across the board. So for Google Gemini first coming on the scene, this is extremely impressive. And if I were OpenAI, I would definitely be looking over my shoulder. Okay, and then let's look at how it performs against MMMU, which is a recently released evaluation benchmark, which consists of questions about images across 6 disciplines with multiple subjects within each discipline that require college-level knowledge to solve these questions. And as you can see here, once again, shots fired to GPT-4. Gemini Ultra beats it at everything except for science. Now, this example is absolutely stunning. And let's read the prompt. Write code to rearrange the subplots in the figure using the latest version of matplotlib. And then it basically says, read the image and move them around. So not only does it have to read and understand the different waves in each of these graphs, but it actually has to rewrite it using code. And it does so. So here it is. Top left, a sine wave, top right, a tangent function, bottom left, an exponential function, and bottom right, a 3D paraboloid. So the new subplot should be, and then it says that, it writes each of them using code, and here's the output. So it rearranged them, and they match up perfectly. So impressive. So successfully solving this task shows the model's capability to combine several capabilities: recognition of the functions depicted in the plots, inverse graphics to infer the code that would have generated the subplots, instruction following to put the subplots in their desired positions, and abstract reasoning to infer that the exponential plot must stay in its original place because the sine plot must move out of the way for the 3-dimensional plot. So here's another really cool example. So prompt, give me 2 ideas that I could use with these 2 colors. So colors, I see blue and yellow yarn. How about a cute blue cat or a blue dog that would also have a yellow ear? Give me 2 ideas for these 2 colors. And now it's green and pink. So the response, I see green and pink. How about a green avocado with a pink seed or a green bunny with pink ears? So the level of understanding from an image and the instructions is truly stunning. And now let's look at modality combinations. So we have an input image. So imagine you're in your kitchen, you take a picture of your kitchen table where you're doing your cooking, you show eggs, you show some vegetables, and you ask, what's the first step to make a veggie omelet with these ingredients? So the model responds with crack eggs into the bowl and whisk them. Then you show an updated image. Thanks for the instructions. I started making my omelet. Does it look ready now? It looks almost ready. You can flip it over and cook the other side. So really, this is what the future of a personal assistant is going to be. Now, the only thing really missing is how is it actually going to collect this information? That's probably why they have the nano model that will fit on any device. And I think about the AI pin device that came out a few weeks ago. Google's probably working on something similar, or they're just going to use their Pixel phones that are ubiquitous. Okay, next, I want to show this video, which is so cool. Basically, it's showing how scientific research is going to be completely appended using Gemini. Let's take a look.
Scientists need to search among thousands of scientific papers for key information and extract them by hand. It's a very common workflow and very time-consuming. In fact, some of our scientists at Google DeepMind face this very problem. They use Gemini to help with it because Gemini has an incredible understanding of science. Taylor will explain more.
So we were looking at this study from 2022. The authors had created a data set by reviewing tens of thousands of scientific papers in genetics. They found a few hundred papers that contained the relevant information, extracted it by hand, and collected it in a table. Studies like this can take a lot of time. We needed to update this data set with what's new over the last couple of years. But that's over 200,000 new open access papers added to this domain since 2021. We couldn't do this manually, so we asked Gemini to help us out. First, we needed to filter for relevant scientific papers.
Okay, so I'm going to pause for a second. So I love that they're using Google Colab for this, but basically what they're about to do is they're about to give Gemini the assignment of looking up all of the different related papers to a specific topic, extracting all of the relevant information from each of those papers, and then boiling it all down into something presentable to a user. All of this would have been done by researchers manually, a hugely time-intensive task that can now be done over a lunch break.
We wrote a prompt, just like this one, telling Gemini exactly what to look for. With its advanced reasoning capabilities, Gemini was able to distinguish between papers that were relevant to the study and those that weren't. For the relevant papers, we wrote a similar prompt, asking Gemini to read the paper and extract the key data for us. We could even ask Gemini to add annotations. This showed us exactly where in the paper Gemini found the information. We ran this at scale, and over a lunch break, Gemini read 200,000 papers for us, filtered it down to 250, and extracted their data.
Wow. So in a matter of an hour, Gemini read 200,000 research papers, extracted and ranked the most relevant pieces of information from each, cited them, and then presented it all in a really easy and digestible format. And Google is really touting Gemini's ability for math and reasoning, which is an incredibly important skill set for a large language model to have. And we've already talked a little bit about that with Q-Star, and maybe Q-Star has to do with ChatGPT's ability to understand and actually reason about math better than what it previously had. But let's take a look at this video talking about Gemini's math abilities.
But this is the amazing part. It can read the answers and understand what was right and what was wrong, and explain the concepts that need more clarification. So Gemini identified some mistakes with problems 1 and 3 here. Let's take a look at 3. Here, Gemini identifies that the formula was correct, but there was a mistake in calculating height. We can ask Gemini to explain in more details why the height is 50 meters instead of 6. I can ask Gemini to explain further. Here, Gemini explains the step-by-step details to solving the problem.
Okay, I'm gonna pause it there. And the last video I wanna show is Gemini turning images into code.
Let's see if our multimodal model Gemini can turn images into code. I'll start with this image of a tree and just select the part I want, and then ask Gemini, can you turn this image into an SVG? This represents the main shapes of a tree. Let's see. That's pretty good. All right, now I want to try a more difficult test. Let's see if Gemini can make an interactive demo in JavaScript. Okay, here we go. A common algorithm for this is called a fractal tree. Okay, this is pretty cool. Gemini even provided a slider, so I can change and move the fractals. It even provided me with the actual code.
All right, so I think what's been really impressive about Gemini, at least from the demos, is its ability to span across different modalities so easily. Videos, images, code, audio, and going back and forth between them, in between them, it's just truly mind-blowing. I'm super excited about testing Gemini. I believe Bard is starting to get Gemini right now. I'm gonna test it all. I'm gonna show you everything I learn. If you liked this video, please consider giving me a like and subscribe, and I'll see you in the next one.